Now that we know how to recognize which side is opposite, which side is adjacent, and which side is the hypotenuse, and we know how to tell whether to use sine or cosine or tangent, if sine, remember that sine uses the opposite side and the hypotenuse side. Cosine uses the adjacent and hypotenuse sides. And then tangent uses the opposite and the adjacent sides. So now that we know how to recognize all that, we're going to start setting up the problems. So we're going to start by just setting up the problems and not solving them. We're going to solve them later. So one of the things that we need to remember, so I talked about that sine uses opposite and hypotenuse. Not only does it use those two sides, but it uses them in ratio to each other. So the sine is the opposite side, whatever the length, the sine of the angle is equal to the opposite side over the hypotenuse. Now, every equation is going to be set up this way. It's going to be a trig function with an angle and a side over a side. So everyone, so the so tells you how to do that, right? S-O-H, sine is opposite over hypotenuse. Opposite over hypotenuse. So that's how you would read that, S-O-H, opposite over hypotenuse. Okay, the cosine of the angle would be adjacent, so C-A-H, ka, right? C-A-H, ka, would be the adjacent side divided by the hypotenuse. Opposite over adjacent and adjacent over, opposite over hypotenuse, adjacent over hypotenuse. So in this case, adjacent to theta, if you go back, look right here, here's our theta. Adjacent to theta is AC. This is adjacent, this is opposite. So adjacent would be AC over the hypotenuse, which is AB. And then we have tangent. The tangent of theta would be TOA, T-O-A. So you would have the opposite side divided by the adjacent side. Opposite over adjacent, which in this case would be opposite, would be BC over AC, which is the adjacent side. Okay, and I didn't do sine up here, but sine would be opposite, which would be BC over hypotenuse, which is AB, opposite over hypotenuse. So, ka, toa, again, that's how you can tell, but not just which sides go with which function, but in what order do you write the equation with. So, let's get some practice writing these as ratios. So, the sine of A. So, we're going to base everything off of where A is. So, the sine of A. So, based on A, on A, 3 is opposite, 4 is adjacent, and 5 is hypotenuse. So based off of A, that is where those sides are located. I want to really point that out because when we change angles, it's going to change which one is opposite and which one is adjacent. So based on angle A, the sine of A, sine is so, opposite over hypotenuse. So compared to A, the opposite side would be 3 over the hypotenuse, which is 5. So the sine of A is equal to 3 over 5, and we will learn to solve that later. Okay, then let's look at the cosine. The cosine of A, cosine, ka, C-A-H. So we need the adjacent side over the hypotenuse. So we labeled adjacent was 4 and hypotenuse was 5. Now you can see already how beneficial it was to go ahead and label your O, your A, and your H so that you only have to think about it one time for these 6 problems. And it is always beneficial to go ahead and label O, A, and H so that you can do minimal thinking or you won't make any mistakes. Tangent of A. Tangent is TOA. So TOA. So tangent is TOA, OA. So opposite over adjacent. So the tangent of A would be 3 over 4. Opposite 3 over adjacent, which is 4. Now, let's show you the difference when they have, when you're going from a different angle. So what if I'm going from C? Well, from C, the hypotenuse is still the same, but now the 4 is opposite and the 3 is adjacent. So now we're going to be using the green lettering, the green labels. So the sine of C, from C, the sine of C, right? Sine is still SOH, S-O-H, so it's opposite over hypotenuse. So it's the side opposite from C, which is 4, over the hypotenuse, which was still 5. Cosine. Cosine is CA, C-A-H, CA, adjacent over hypotenuse. So from the cosine of angle C, we'd use the adjacent to C, which is 3, over the hypotenuse, which is 5. And then we have our tangent. Tangent is TOA. So tangent would be OA. So we need our opposite from C, which would be 4, over our adjacent from C, which would be 3. Now, just a quick note, look and see how these relate to each other. Notice that your cosine of A is the same as your sine of C. Your sine of A is the same as your cosine of C. And your tangents are reciprocals of each other. So that's just something interesting to note. But it does show you that it matters which angle you originate from and which angle you're finding the function of. So let's take some actual problems that we're going to be doing again later to solve, and let's see if we can decide, would we use sine, cosine, or tangent, or let's set it up. So now we have to do several things, right? We have learned how to label O, A, and H. So that's what we're going to do first. We're going to label O, A, and H. Then we're going to decide, do we use sine or cosine or tangent? That's what we have to decide. And then once we do that, we can set it up, okay? When we set up our equation, then we can use our SOH, CA, TOA, opposite over hypotenuse, adjacent over hypotenuse, tangent is opposite over adjacent to set it up. So here's what it will look like every time. So first, find your angle that's in question. Decide, label your O, your A, and your H. So my opposite side doesn't have anything. My adjacent side has an X, and my hypotenuse has a 16. So of the ones that I have, the ones that are labeled are A and H. So A and H is cosine. So I know that I need to use cosine. So here's what we do. We say the cosine of the angle, which was 51 degrees, the cosine of the angle equals the adjacent side, which is X, over the hypotenuse, which was 16. Just like that. The cosine of the angle equals the side over the side. You always have to have something attached. Cosine can't live by itself. If you hit the cosine button on your calculator, it's automatically going to open up a set of parentheses because it wants you to give it something. So cosine can't survive on its own. It has to have something that it's taking the cosine of. So let's look at this next one. Let's practice with it. Find the angle that's in question. Decide how are the sides that you have. So I have the hypotenuse, which is empty. X is the opposite side, and 25 is the adjacent side. So I've labeled my O, my A, and my H. Then I decide, am I going to use sine or cosine or tangent? Well, I have O and A. Those are the two sides that I have information for, O and A. So if I have O and A, that's tangent or TOA, right? So I'm going to use tangent. So I would write down tangent of 56, the tangent of the angle, is equal to the opposite side, X, over the adjacent side, which is 25. This last example, I have a 38-degree angle. That's my angle in question. I need to decide. So 16 is hypotenuse, x is opposite, and this empty side is my adjacent. The two sides that I have are opposite and hypotenuse, O and H. So, ka, toa. So that would be sine. So, SOH would use sine. So, you write the sine of the angle is equal to the opposite side, x, over the hypotenuse. So when you set it up, it is always the trig function, right? So it's always sine or cosine or tangent of the angle is equal to a side over a side. Okay, this angle is imperative. You have to have an angle that comes after the sine, the cosine, or the tangent. Because you have to know, the reason it's important is you have to know which angle you're basing everything off of. That's why you have to name the angle, is to say everything that you're going to base it off of. So we need sine or cosine or tangent to give us our sides. So, ka